everyone and welcome back to my YouTube channel. Today we will start electrochemistry for class 12. Now what is this electrochemistry? Electrochemistry is the branch of science that deals with the study of electrical energy and chemical energy and the interconversion of each. How to convert electric energy to chemical energy and how to convert chemical energy to electrical energy. It is all studied in electrochemistry. Now let's start the chapter with some basic terms or definitions. First term is conductor. I think you have studied in lower classes also. The materials from which current can be passed, they are called conductors. Now conductors are of two types. Conductors are of two types: metallic conductors or electronic conductors. Second is electrolytic conductors. Now metallic conductors are those conductors in which current is passed by the flow of electrons. Electrons are flown from one terminal to another terminal. Current is passed by flow of electrons. Examples: metals. That's why they are called metallic conductors. In metals, current is passed by flow of electrons. But electrolytic conductors are those conductors in which current is passed by dissociation of electrolyte. But electrolyte must be in a fused state or in a aqueous solution. Electrolyte must be in fused state or in a aqueous solution. So current will pass by the dissociation of electrolyte in aqueous solution or in a fused state. Examples: aqueous solutions of acid, base, salt. Aqueous solution of acid, base, salt, they behave as a electrolytic conductors. Current is passed by dissociation of electrolyte. Dissociation, or we can say ionizations, split into ions. Right. Next, electrolytic conductors. Strong electrolyte and a weak electrolyte. In strong electrolyte, there is a complete ionization. Complete ionization in a aqueous solution, or we can say they have a high degree of ionization. Complete ionization, or we can say high degree of ionization, they are called strong electrolyte. Examples: KCl aqueous solution, sodium chloride aqueous solution, potassium sulfate aqueous solution, they are a strong electrolyte. But weak electrolytes are those electrolytes which have less degree of ionization, or we can say simply they don't dissociate completely. Don't dissociate completely in a aqueous solution. Examples: acetic acid, carbonic acid, etc. They are considered as a weak electrolyte because they possess a less degree of ionization. So we have two types of electrolyte: strong and weak electrolyte. Now next few terms again. First is a resistance denoted by R. What is resistance? It is the oppose of flow of current. That is resistance. It never allowed to flow current. It opposes the flow of current. And mathematically, resistance of any wire or any metal is directly proportional to length, inversely proportional to its cross section area. Directly proportional to length of the wire or any conductor, and inversely proportional to cross section area. So we can combine R is directly proportional to L by A, and if we put the value of a constant, R equal to rho into L by A. Here rho is called resistivity. Rho is called resistivity. So what is resistivity? It is the property of any material to oppose the flow of current. Resistance itself opposes the flow of current, and now resistivity, it is the property of material. Every metal has different resistivity, right? So we can conclude the formula of resistivity from here. So resistivity equal to R into A by L. Right? So we have the basic two formulas: resistance and resistivity. Unit of resistance is ohm, and unit of resistivity is ohm centimeter. R ohm is centimeter square by centimeter. So 1 centimeter will be deduct ohm centimeter. Resistivity, again, it is the property of material to oppose the flow of current, and resistance itself oppose the flow of current. Right? Next two terms we are going to reverse it. Third term is conductance. It is the ease of flow of current. So we can say it is the reciprocal of resistance. So C is 1 by R. Why? Because R opposes the flow of current, but it is the ease of flow of current. C equal to 1 by R. R itself is rho into L by A. A is here. So we are going to introduce new fourth term. Conductivity, denoted by K. It is the property of material to allow the ease of flow of current. So mathematically K equal to 1 by rho, just reciprocal, just opposite of resistivity. So 1 by rho can be written as K. So we can put it here. C equal to K into A by L. And we can find the formula of conductivity also. K equal to C into L by A. This is third formula and this is right? Unit just opposite of resistivity, ohm inverse, centimeter inverse, and we can conclude it from here. K equal to C into L by A. K is conductivity, C is conductance, and L by A is considered as a cell constant. So conductivity is the product of conductance into cell constant. From one formula resistance, we can conclude all these three formulas, right? I am going to give a short summary of all these formulas. R equal to rho into L by A, resistance. C is equal to 1 by R, conductance, reciprocal of resistance. 1 by rho may be written as K. Third, rho equal to R into A by L. And fourth, K equal to C into L by A. One numerical may be asked. Find the resistivity, find the conductivity, find the resistance, find the conductance. And you make sure you must write the unit in a numerical. Resistivity unit is ohm centimeter and conductivity unit is ohm inverse centimeter inverse. Now next fifth is the important term, that is specific conductance. We have concluded that K equal to C into L by A. Conductivity is the product of conductance into L by A. L by A is cell constant. But if L equal to 1 centimeter and area equal to 1 centimeter square, so definitely volume will be 1 centimeter cube, and 1 centimeter cube may be written as a 1 ml. So we can put the value here, K equal to C into 1 ml. So specific conductance K is the conductance of 1 ml of an aqueous solution of an electrolyte. Conductance of 1 ml aqueous solution of an electrolyte. So specific conductance is the conductance of 1 ml aqueous solution of an electrolyte. Clear? Next is molar conductivity and equivalent conductivity. Next is molar conductivity. It is the conductivity of it is the conductivity of all the ions produced by 1 mole of an aqueous solution of an electrolyte. Conductivity of 1 mole electrolyte aqueous solution, that is called molar conductivity. Now you don't need to cram its formula. We will understand the formula. We have studied here, we have concluded conductivity of conductivity of 1 ml electrolyte aqueous solution is K. 1 ml conductance is K. And if we have the volume V, so conductivity of V ml electrolyte aqueous solution will be K into V. Now, what is this V? This is the volume that contains 1 mole of electrolyte. V is the that volume that contains 1 mole of electrolyte. We can use the formula of molarity. Molarity is number of moles present in a given volume of any solution. So if Mb equal to 1, if we have 1 moles of 1 mole of an electrolyte, so M equal to 1000 by V, V will be 1000 by M. So I am going to give the name to this equation. Conductivity of VML that contains 1 mole of an electrolyte is called molar conductivity. So we can change this to, this is a molar conductivity equal to K into V, and V we have 1000 by N. So molar conductivity equal to K into 1000 by M. K is conductivity, 1000, M is the molarity or concentration of an electrolyte. What will be its unit? K we know, its unit will be ohm centimeter square. Sorry, K equal to C into L by A into 1000 by M. C is ohm inverse. This is centimeter inverse into 1000 by M. M is number of moles by volume. Right? So unit will be ohm inverse. Volume is centimeter cube. So final will be centimeter square mole. This is the unit of molar conductivity. Ohm inverse centimeter square per mole. Right? Again, it is the conductivity of V volume that contains 1 mole of an electrolyte, or conductivity of all the ions produced by 1 mole of an aqueous solution of an electrolyte. Molar conductivity equal to K into 1000 by M. Right? Next is equivalent conductivity. Next is equivalent conductivity. It is the conductivity of 1 gram equivalent of an electrolyte. Conductivity of 1 gram equivalent of an electrolyte is called equivalent conductivity. So again we can say equivalent conductivity equal to K into V. V is the that volume which contains 1 gram equivalent, And 1 gram equivalent concept we have studied in a normality. M equal to number of gram equivalent by volume into 1000. So V equal to gram equivalent by N into 1000. And we have a 1 gram equivalent. So we will be here 1000 by N. So we can put the value equivalent conductivity equal to K into 1000 by N. Equivalent conductivity equal to K into 1000 by N, and N is the normality of a solution. Again, unit will be ohm inverse centimeter square per equivalent, right? And we, as we know, normality equal to molarity into n factor. We can conclude relation between molar conductivity and equivalent conductivity. So equivalent conductivity equal to K into 1000 M into M. And now this is K into 1000 by M is molar conductivity. So equivalent conductivity equal to molar conductivity divided by M. Right? We can conclude from here molar conductivity equal to equivalent conductivity into molar conductivity equal to equivalent conductivity into n factor. And if n factor is 1, let's draw here. Molar conductivity is the equivalent conductivity into n factor. If n factor is 1, then molar conductivity equal to equivalent conductivity. But if n factor is greater than 1, then definitely molar conductivity will be greater than equivalent conductivity. So what is the conclusion? Molar conductivity greater or equal to equivalent conductivity. Molar conductivity can't be lower than equivalent conductivity, right? So this is the basic introduction and basic conclusion of chapter electrochemistry. In next segment we will start up further topics. Stay at home, keep learning, and if you still didn't subscribe my channel, subscribe. Thank you.